Hello, hello, wonderful, wonderful students. This is page 4 of our foldable for section 5.7, solving rational expressions or rational equations, but we've been using expressions, so solving rational expressions. And this is also a double foldable, so there's going to be two. So just in case you didn't catch in the last two videos, we're actually taking the 4 foldable and we're only using the middle line to split it into two pages, or two halves. Okay, so for our first foldable, or for our first part of the foldable, I'm going to zoom in a little bit. We have our 11 over x plus 1 equal to x plus 2 over x plus 1. Alright, so once again, the first thing we're going to do here is do our LCD, which of course is the, very good, it's the lowest common denominator. But these here both share an x plus 1, so we know our lowest common denominator is our x plus 1. Alright, so same thing that we did before, we're going to multiply by the LCD. In order to do that, we're going to, the reason why we're doing that is because we're going to clear our fraction. Alright, so go ahead and do that. Just go ahead and do our little brackets here. And we're going to multiply by our x plus 1. This is a little easier than a little less work than the other ones we've done because it's just one LCD instead of having two expressions. We only have one expression, which is our x plus 1. So let's go ahead and rewrite that as 11 over x plus 1 times our x plus 1 equal to our x plus 2 over x plus 1 times our x plus 1. So it's kind of easy to see that we have two common factors. Our first one here is our x plus 1 and our x plus 1. Just go ahead and factor out. And then we have another one here that is our x plus 1 and our x plus 1 on top as well, the numerator. So we're going to reduce those out. And what we're left with is just our 11 equals to x plus 2, which is a simple one-step equation. So we're going to subtract 2 here, subtract 2 here. This is 9 is equal to x plus 0, which we need to write. Associated property of equality says that we can change this to from 9 equals x to x equals 9. So this is the answer we got for this one here. Okay, so now the first thing we're going to do is check for our excluded values. Let's see. Yeah, let's check for our excluded values. We'll do it up here. Excluded, since we have a lot of space. Values. So remember, our excluded values are based upon our LCD, which is our x plus 1, and we're going to set it equal to 0. And if we subtract 1 here, clearly we can see that x is equal to -1. So it means our excluded value is not what we actually got. Go ahead and box it up here. Excluded values are very, very important. Muy importante too. And they help us find a bunch of the asymptotes or the holes when we're looking for our graphs. All right, so now that we did our excluded value and it wasn't that, we're going to do our check. We're going to check to make sure that x is equal to 9 and it's not an extraneous solution. So we go ahead and put 9 back into our equation. So we had 11 over x, which is 9, 9 plus 1 equal to 9 plus 2 over 9 plus 1. And we rewrite this equation again. We have 11 over 9 plus 1 is 10 equals 9 plus 2 is 11 over 9 plus 1 is 10. So it checks out. So this is a true statement. Ooh, I had to write a little curve, sorry. I should rewrite it. I got a little time, right? Ooh, shake, shake. So this is a true statement. Alright, so we go straight to our conclusion. So we have therefore, comma, x equals 9 is our solution. Go ahead and box this off as well. What a nice pen. Look at this pen color, so beautiful. All right, wonderful students. That was part 1 of Foldable 4.